Hi there, my name is Miss Townsend and I love math. This is a video for data management students who are preparing for the exam. From the large exam review, it's question 6C. In question 6, we have the word career and we're asked to rearrange the letters and make a new 6-letter word. And of course, word doesn't mean something that is in the dictionary, just an anagram or a rearrangement of the letters. So in question 6C, specifically, we want to create an anagram that starts with the letter R or ends with the letter R, but not both. So I'm doing this video because I was asked to, and also I think that originally the answer I had was actually wrong. So let's look at how to do this question. So we know that we are basically anagramming or arranging six letters, but they're not all different. There's 2 R's and 2 E's. And so we want to start with an R or end with an R, but not both. So let's think about what happens if we start with an R. So if we start with an R, we do not want to end with an R. And that means we're going to end with a C, an A, or an E. And it doesn't matter that there's 2 E's here because the letter E is the same regardless of if it's this one or this one. The letter E is the letter E. So that looks like it gives us 3 choices. But that's not really the way to think about it. The problem is that if I start with an R and end with a C, then in the middle here, I would have another R, an A, and 2 E's to rearrange. And that would do, 4 factorial because of 4 items, and then there's 2 E's. And I would do that math. If I started with an R and ended with an A, then in the middle, I would have the other R, a C, and 2 E's. So I would do exactly the same math with RCEE as I would with RAEE. No problem there. But if I start with an R and end with an E, the middle 4 letters would have to be C, A, R, E. And this time, because of the E on the end, I only have 1 E in that middle section to rearrange, which means that my approach, or the math I have to do to rearrange C-A-R-E, is different from the math to rearrange when there's 2 E's. So that means we're going to have to separate this into cases. So I can leave C and A together and treat that as case 1, and I'll do E as case number 2. And then we'll worry about the fact that I'm only right now focused on start with an R, but we'll deal with that later. So let's start with case 1. Case 1. We're going to start with an R, and we're going to end with A or C. So if we think again about the 6 positions that I need to place the letters, we know that this has to be an R, and there's only 1 letter R in the English language, so there's like 1 choice there. A or C, so I'm given a choice. I can pick between 2 different things, A or C, so that's 2 choices as to what goes here. And so then let's look at what's going to be left over to arrange into those 4 positions. So I'm going to have the other R for sure. I'm going to have the 2 E's, and I'm going to have either A or C, whichever one is sort of left over. So A or C is going to be left over. So in the middle, I'm going to have 4 things to arrange into these 4 positions, and 2 of them are going to be E's. So in total, if I start with an R and end with A or C, the fundamental counting principle that I have 1 choice times 2 choices. So the R is 1 choice, the A or C is 2 choices. And then I'll have 4 objects where 2 of them repeat. So this is now not a choice, right? I'm like, if I end with a C, then this one definitely has to be the A, right? So it's not like I'm multiplying by 2 again. So 4 factorial divided by 2 factorial is 12. So that gives me 24. So there are 24 ways of arranging the letters in the word career if I start with an R and I end with A or C. So then let's look at case number 2. So here we're going to start with an R and we're going to end with an E. So start with an R, end with an E. So like there's 1 letter R, there's 1 letter E. Again, the letter R is the same regardless of which one I pick. So there's 1 choice here. So we really only have to worry about the math that comes in the middle. So what's happening in the middle is I have the other R, the other E, an A, and a C. So these 4 objects have to go into these 4 positions. So there's 4 objects to fill 4 positions, which is 4 factorial. 4 times 3 times 2 times 1 is 24. So if I start with an R, case number 1 and case number 2, that's it. Like there's no other letter I can end with because we're not allowed to end with an R. It either ends with an A, a C, or an E. So therefore, if I start with an R, then I have 24 if I end with an A or C, 24 if I end with an E. So there's 48 different ways of starting with an R and ending with an R. So what about the opposite, but I also need to consider it. What about ending with an R but not starting with an R? So we have to do that. And so the nice thing is that if I end with an R, all of the logic and math that I just did is going to just be repeated, because I know that the start position, since it cannot be an R, is either A, C, or E. So I would again divide it into cases, and I would end up with exactly the same math. So there are 48 ways of ending with an R without starting with an R. So therefore 48 plus 48 gives a total of 96 possible combinations or rearrangements of the word career that start with an R or end with an R, but don't do both. And just in case you want to see, there's another way you could have done this question. So I'll just show you that another thing you could have done is I'm going to start with an R and count all the words that start with an R, even the ones that end with an R. And I'll explain what we do. I'm going to do a complement. So if I start with an R, then these letters need to just be arranged into these 5 positions. So there's 5 objects. 2 of them are both E's. So 5 factorial divided by 2 factorial is 60. But some of those 60 things gave me an R in this position, and I kind of didn't want them. So I'm going to now subtract what happens if I start with an R and I end with an R, because I don't want those. But I counted them here, and I don't want them. So if I start with an R and I end with an R, then I have the letters A, R, E, A, C, E, E in the middle, which is 4 factorial divided by 2 factorial arrangements, also known as 12. So if I subtract 12 from 60, what I'm left with are the arrangements that started with R, and I then removed the ones that also end with an R. And you'll notice I also get 48. And again, because this was the logic of starting with an R, I could repeat all this logic for ending with an R and do 48 times 2 again, and that would still give me 96. So that's the answer to that question. I hope that was helpful. Bye.